Hello students, I have told you about the simple harmonic motion yesterday, the motion of the projection in a uniform circular motion. And now today I will take the displacement, velocity and acceleration equations of SHM. Equations of SHM. Number one, displacement equation. I told you earlier that y equal to a sine omega t plus phi. Phi is the initial phase difference. If suppose phi is equal to 0, then we will have, if phi equal to 0, then y equal to a sine omega t. And you see that this is the function of sine. So the value of y will vary according to what the sine term in this equation. So if we take sine, then we will get this SHM, and then we are taking it to be the cos, a cos omega t. Even we are getting to this one, in place of y we will write down the x, as I told you yesterday. This is suppose number one. Now velocity equation. Velocity equation. So if you differentiate to this one, differentiating equation 1, dy upon dt equal to d upon dt into a sine omega t, and you will find this is now a omega cos omega t. So this is now velocity v. Further you can write it to be now this v equal to a omega square root of 1 minus sine square omega t, using the trigonometric relation that this sine square theta plus cos square theta equal to 1. So now I can write the value of sine square theta from this first. V equal to a omega square root of 1 minus a upon y whole square. This is, sorry, y upon a. Here this sine omega t is equal to y upon a. So this is equal to omega square root of a square minus y square. This is another form of the velocity. So this is the velocity equation. And now this is now number 2. Now acceleration. acceleration. equation. Differentiating equation 2, dv upon dt is equal to d upon dt into a omega cos omega t, and this is equal to a omega square sin square omega t, sin omega t. The differentiation of cos will be sin with a minus sign and multiplied by omega, so omega into omega is omega square, and cos will be converted into sin. So a sin omega t. This is now acceleration. So this we denote by alpha. Alpha. So this is the equation in terms of time, and also this can be written as minus omega square by. Now this a sin omega t, a sin omega t, we will use this y. So this is now one more form. Now for force, restoring force. Now we know that this F equal to minus ky. So this is now your minus k and y omega square. F equal to m into alpha, this m, and this alpha equal to omega square by. So this is equal to minus k y. This is equal to f. So if you write down the value of y in terms of this sign, then this will be now a sin omega t. So this is now minus k a sin omega t. This is f. So we can write it like this or write like this, where k equal to m omega square. So you can have the graphs for these, all these terms. This is like this. Suppose this is now 0. Here we take the y, and this is now time t. 0, and this is now your pi by 2. So now suppose your t by 4. Then this is t by 2, and this is 3t by 4, and this is 4t. Now similarly we will have here it is for t, this is for t by 2, this is for 3t by 4, this is for t. This we take the velocity v 0. Similarly we will have this alpha. This is now 40. It is all 40. This is now for alpha 0. It is for this t. This is now your so much. This is now so much. This is now your to be so much. So these all correspond to this value, and this I take it to be like this. So we will draw an inference for all these. So you can see that this y equal to a sin omega t, that the term arises from this. Like this. V equal to a omega cos omega t. So this arises from here. This is now your ty2, and then like this. If we take it for alpha, this is again a minus term, so we will find it to be here. Like this. So you can see that here this is the maximum displacement A. Here we have this maximum displacement minus A. This is A omega. Here we will have this minus A omega. Here this term is taken to be your A omega square. And then this term will be here. This is now A omega square. This is for alpha. This is now velocity. This is for displacement. Similarly, we have this force. This is now 0, this is now force F, this is now time t. This is now your Ty4, this is Ty2, this is Dt4, and this is your t. Then here we are having again this sign term, but we have this minus sign, so this will be like this. And here this is for minus Ka, and here this will correspond to Ka. Ka. So you can see that the graph for alpha and F are the similar. You can see the similar. So all these graphs shows that thus y maximum equal to A and y minimum equal to 0, and V maximum equal to A omega and V minimum equal to 0, and alpha maximum equal to A omega square and alpha minimum is equal to 0. Similarly, the force F maximum equal to Ka and F minimum equal to 0. So you can see that when the particle the maximum displacement will be equal to the A, the amplitude, and maximum velocity will be A omega, and maximum acceleration A omega square, and maximum force equal to Ka. So this is in terms of the time t. Now if we take in terms of the displacement, now we can have the force in terms of displacement, the velocity force F equal to minus Ky, and acceleration alpha equal to minus omega square by, and the velocity v equal to omega square root of a square minus y square. So we can write down it to be like this. B square upon omega square equal to a square minus y square. B square upon omega square plus y square equal to a square. So we divide by a, then b square upon a square omega square plus y square upon a square equal to 1. So this is the equation of ellipse. So now we can draw to all of these. This is suppose 0, this is now force F. This we take here the y displacement, then we will have it to be like this. Here this is so much, this is, so you can see that here this is now negative and here the force is negative, so here we will find the force is negative but y is positive. Here the force is positive but y is negative. So this is the positive value and this is now negative value. Here the positive and here the negative. Now similarly this shows that the particle goes like this and then it comes back, and then this is here, then this is now again coming back. This is showing the position, and similarly we will have this is your alpha so much, this is the origin, and this is now your y. So this will again like this. Similar form is here. Like this. So you will have the motion like this. And this is again, this is positive, this is negative, this is positive, and this is again a negative. So this is positive. Here is now negative. This is now positive, and this is now negative. So this is the graph for this acceleration. And now for this graph we can have the value like this. This will be like this, in the form of ellipse. This is not 0. Here we take the V, and here this we take the Y. So this is now y equal to a. This is so much. This is now a. So this value will correspond to v equal to a omega, where y equal to 0. This value will correspond to a omega, and this will correspond to a. So you can have that the maximum velocity is again this a omega, and the minimum velocity of this one, when here this is now 0 at this point. So these are the graphs showing the variation of force, acceleration and velocity with the displacement, and I show you the graphs showing the variation of all these quantities with respect to time. So this is all about the equations and their graphs. So you like, share and subscribe this video. Thank you.